Hi, this is Lab 1. We're going to study linear motion using Newton's second law. Doing some calculations, we can reach this form from this original one. And if we assume that f net is equal to 0, that means that this whole term is equal to 0 and the final velocity is equal to the initial velocity, which means that the object is moving with a constant velocity. So in order to do the experiment, I have this video here of this rubber ball moving in this direction. First I need to set the true length, that's it, and then I need to set the coordinate system. This is the origin point, the y-axis and the x-axis. We need to set the directions also. This is the positive direction when we go to the right, and the negative direction is when we go to the left. So if we track the motion of the ball here, this is the mass of the ball, we can get these data. This table here represents t, time in seconds, and x, the displacement in meters. This axis is displacement in meters, and this is the time in seconds. We can see that this graph here is nearly a straight line. If we consider these first 2 points here, we can find out that the velocity of the ball is -1 meter per second in the x direction. Now we open Python to make our computer model. So here we set the mass of the ball to 50 grams. This wouldn't really matter, it won't affect any calculations because we are assuming from the beginning that f net is equal to 0 and this whole term is equal to 0. We can see here that the initial position of the ball is 0 and the initial velocity is -1 in the x direction, and f net is 0 as we are assuming from the beginning. So now we're ready to test that. So if we run that, we get these results. This is how the ball is moving. This is it exactly, and here's the graph. Here is the position in meters, and this here is the time in seconds. And comparing the data we got from Python with the data we extracted from Tracker, we get this graph over here. This axis represents the position in meters and this axis represents the time in seconds. The red graph over here represents the data we extracted from Tracker, and this blue graph over here represents the data we got from Python. Now if we look here at this red graph, we might see that there's a little curve right here, and the reason we see this is because there was some little wind blowing in the same direction as the ball was moving. So this maybe made the ball a little faster, maybe made it a little slower, but this was actually great because it kept the f net equal to 0 as it worked against the fraction from the ground, so it kept the f sub net equal to 0, and this made the velocity constant. Now we have two very important questions that we should address in this report. The first one is, what if we flip the axis and coming back to Tracker, and we can flip this axis right here. Now we notice the curve has changed its slope. It's actually the same points but in a positive direction, and the x coordinate of all the points has changed its sign. It was negative in the beginning, but now we notice that it's all positive. And if we calculate the velocity again, we find that it's +1 instead of -1, and then we go to Python, we change that here, we make it 1, and then we run the program to see the results. Yes, that's what we get here. The ball is moving in the same velocity but in the negative direction, in the positive direction in this case, and it's the same graph but the slope is positive in this case instead of negative. So that means that if we flip the axis, we get the same results but in the negative direction, and as for the curves, we get the same curves but in a negative slope. And if we compare the curves again, we find that they're the same, but the slope of the two curves would be positive instead of negative. And now we go to the second question. How many pushes and pulls are added together to give zero net force? Okay, now we go back to checker, and we've said earlier that there was some air blowing that way, and we know that there's friction coming from the ground on the ball that way in the positive direction, and this one in a negative direction, and the gravity is here, and there's the reaction of the ground here. So all these forces must add together to give zero net force. And thank you for watching.